welcome to my video lessons. In today's session I am going to discuss about the SCR ratings as well as the DIAC characteristics. Before entering to today's session, just I will recall once the previous previous session. Right, in today's topic I am going to explain about the digestor ratings, that is the SCR ratings, and operation of the DIAC, cross-sectional view of the DIAC, VI characteristics of the DIAC, and applications of the DIAC. Right. See, before entering to this, we will just recall once. Right. In the last session, I discussed about the about SCR. What is an SCR means? SCR is a silicon control rectifier. It has 3 terminals: anode, cathode, and gate, and 4 layers. It is a 4-layer device, PN, and it has 3 junctions. Anode is from the outer P region, and anode terminal, and the cathode terminal is from the outer N region, and gate is near to the cathode from the inner P region, inner PGA region. Right. This SCR, the equivalent circuit we can can be 2 transistors, 2 complementary transistors. That means it is equivalent of 2 transistors. One is PNP and one is NPN connected together. That means the output of the one transistor is connected to the input of the another transistor, and it is like that way continuously. That means the effect of any one of the transistors is applied on the another transistor output also. Right. The total anode current in this SCR is the summation of the 2 transistor output currents, IC1 and IC2. Right, II equals to IC1 plus IC2. This is about the 2 transistor energy of the SCR. Come to the VI characteristics of the SCR. In the previous session, I explained in detail about the VI characteristics of the SCR. Right, when a positive anode voltage is applied with respect to the cathode without the gate voltage. That means when the gate current is 0, though the voltage is a small voltage is applied between the anode and cathode. Now 2 junctions J1 and J3 are in forward bias. J2 is reverse biased. This and the diode is in off state. The device SCR is in the off state. Though it is in the off state, due to the J2 is reverse bias, but due to due to the minority charge carriers, there is a small leakage current, that is called forward leakage current, and we can say and the device, the SCR is in the forward blocking state. That means a small amount of current flows in this blocking state. That current is called forward leakage current. Right. If the anode voltage is further increased, that means it is increased, though the gate is 0, the gate voltage is 0, the anode voltage is going on increasing. At particular voltage, the junction J2 breaks due to the avalanche effect. J2 breaks, and the current starts flowing from anode to cathode. That particular voltage is called forward breakover voltage. That means whenever this anode to cathode voltage reaches the forward breakover voltage, this junction breaks and the current starts flowing from anode to cathode, and the SCR is in the on state. This state is called forward conducting state or forward conducting mode. That means the device is on state in this mode. The device is now the SCR is in the on state. Now there is another thing. Right, this device can be triggered on with by applying a positive gate voltage also. The SCR can be triggered by applying a positive gate voltage also. And the third case, there is another mode, that is reverse blocking mode. What is reverse blocking mode means? If the cathode is connected with positive with respect to the anode, that means the device, that means junction J1, J3 are in reverse bias, J2 is forward bias. That means there is no conduction between the anode to cathode, and there is no current flow from anode to cathode. The device is in the off state. Though due to here also the same case, due to the minority charge carriers, a small amount of current flows in the order of milliamps to microamps, very small amount of current, that is called reverse leakage current, and this mode is called reverse blocking mode. The device is in the off state. This is about the VI characteristics of the SCR. And now come to this today's session. In this session, first I will discuss about the thyristor ratings. What is rating first? Ratings means generally every manufacturer specifies the specifications of specifications and what are the minimum and maximum voltages required to operate this device. If those values are exceeded while operating using this device, if those values are exceeded means the device may damage. So for that definitely we need to follow those ratings, we need to maintain those values, and generally it should be lesser. For the reliable operation of the thyristor, the device should be operated within the specified limits. Who will specify these specified limits? Means manufacturers. These safe limits are called thyristor ratings. These thyristor ratings are safety working margins which are generally these are higher than the normal working values. For reliable operation of a thyristor, it should not exceed the safety working margins. Otherwise, it may damage. It may. That means we need to maintain we need to follow these values while operating the device. Right. Classification of SCR ratings. Generally, these SCR ratings are classified into three: continuous rating, repetitive rating, and non-repetitive or surge rating. Continuous rating is it is related with the continuous working condition of the device. Continuous ratings are when the device is in the continuous working condition. Repetitive rating, generally so in some cases the device may periodically on and off actions. So the rating is this repetitive ratings are useful when the device is switched on periodically and the device is going into on state periodically. In that cases we need to follow these repetitive ratings. Non-repetitive or surge rating, it corresponds to the maximum permissible non-repetitive current and peak voltages which the device can withstand during a surge. This is about non-repetitive rating. And what are the general thyristor ratings of the thyristor ratings means anode voltage rating. Anode voltage rating, we know that there are three terminals: anode voltage rating, and the second one is current rating, power rating, dV by dt rating, that means rate of change of voltage with respect to time, and di by dt rating, turn on and turn off times, latching and holding currents, and the temperature ratings. These are the general thyristor ratings. We will discuss each and everything. Right. These all the ratings are generally specified by the manufacturer. Right. Anode voltage rating. It anode voltage rating is the maximum voltage that can be applied across the anode to cathode without any breaking at the junction area. That means if this anode voltage is increases further and further, if it exceeds the this specified value, that means the device may breaks. That is the reason we need to maintain this. It is the maximum voltage that can be applied across the device without causing any breakdown at junction area. Without causing any breakdown at the junction area. If the junction breaks means the device gets damages. That is, so we need to maintain current rating. See, there are many current ratings with repetitive and non-repetitive waveforms. Right? If current this current should not raise the thyristor junction temperatures for short overloads of the current. If there are overloads means if this current increases means the junction temperature increases. We know that the junction temperature is increasing means this heat produces, it may this heat may damage the device. Right. That may, so we need to maintain this. Hence for that reason the operating current should be within limits for safe working of the device. The operating current should be within the limits for safe of the device, safety of the device. right? Turn on time. Turn on time. The name itself, that is a turn on. This is the time taken by the device to reach its full conduction mode. That means the time required to trigger the device to come to the full conducting mode. Right? This these are the characteristics for turn on time. There is anode current and gate current. Right? See here, this turn on time is the summation of two times, that is TD and TR, delay time and rise time. Delay time and rise time. See, delay time is the time required to reach its 10% of the maximum value, and rise time is the time required from 10% to 90% of the current. Right? See, if you see here, delay time is from this time to this for 10% of its value, and TR is the time rise time to anode current is from 10 to 90% of the maximum current. Turn on time is the summation of delay time and the rise times. Generally, the turn on time is 2 to 10 microseconds for a SCR. And dV by dt rating, rate of change of voltage with respect to time. This rating indicates the maximum rate of rise of voltage from anode to cathode without any harm to the device. That means it is indicating the maximum voltage from anode to cathode with respect to the rate of rise of voltage, to protect the device. This is a maximum rate of rise of voltage from anode to cathode. See, this rating is with respect to time. So with time, that rating should not exceed. If it exceeds, means the device breaks. Similarly, there is one more rating, current rating, di by dt, rate of rise of current with respect to time. It indicates the maximum rate of rise of current from anode to cathode, generally anode current, without any harm to the device. Suddenly, if anode current increases, that means junction temperature increases, heat produces, device breaks. So this is the that rating. It should not exceed that rating, di by dt rating. And turn off time. See, generally turn off time is the time required to turn off the device. This turn off time is when the device is in the off state. Generally, when the cathode is positive with respect to anode, in that case the device is in the off state. In another state also the device is in the off state until the forward breakover voltage. Until in the forward blocking mode is also the device is in the off state. So when reverse voltage is applied to thyristor, the time taken from zero current point to time when thyristor regains its full blocking voltage is called turn off time. That means from the initial value to that means zero value to the time, and the thyristor retains its full blocking voltage until it turns on. The time is called turn off time. Right? Again, this turn off time consists two times: reverse recovery current time and recombination time. Reverse recovery current time and the recombination time, and it also has two times: recovery time and recombination time. Generally, there is one more condition: this circuit turn off time must be greater than the device turn off time for safe turn off. That means the device turn off time should be always less than the circuit turn off time. Turn off time is combination of these two times, and the circuit turn off time must be greater than the device turn off time for safe turn off of the circuit. You can see the turn off characteristics. This is the T off time. Sorry, here it is on. Generally it is T off. Reverse recovery time plus recombination time, TR plus TRR. TR and TRR. This is the reverse voltage. Whenever the reverse voltage applied, the time taken from zero current point to time when thyristor regains its full blocking voltage is called turn off time. TRR plus TR. And the temperature rating. Temperature rises rapidly based on the even for short overloads of the current. Whenever there is a variations in the current means, when the load variation means the current varies. With the varied load, the junction temperature also varies. That means the temperature at the junctions is varying, means heat produces. That heat is generally delivered in the form of power. For this, generally the temperature rating should be usually 180 degrees for steady state conditions. For the thyristor, the junction temperature under steady state condition should be 125 degrees. It should not exceed this temperature. If it exceeded means the device will be breaks due to the more heat and high power. Okay, right. Thyristor ratings, and there are different ratings. We need to maintain those ratings for proper maintenance of the device. And these generally the ratings are specified by the manufacturer. Next, we will discuss about the DIAC. DIAC. See, if the name itself, if you divide this into two parts, di and AC. Di means generally this word is from the diode, and there is one more meaning we can say. Di means two. It has two terminals and it works on AC conditions. This DIAC is also a power device. It is also a bidirectional thyristor diode. Bidirectional thyristor diode. DI is indicating, DI is the two letters from the diode, and AC is bidirectional. That is the reason it is DIAC. Right? Here you can see the symbol of the DIAC. It is a two terminal device. Those two terminals are T1 and T2. See, if you observe this diagram, the symbol of this diode, two PN diodes connected back to in series. See, T1 to T2, one PN junction you can consider, T2 to T1, another PN. It is both the diodes. Bidirectional thyristor diode, two terminals T1 and T2. It is a two terminal 5-layer bidirectional device, and two terminals. You can see the construction of the DIAC. DIAC has, if you see, generally P and P, and three layers. P and P are the three major layers, and the bottom of it near the T2 there is another layer N, and T1 is near the N plus region. Overall there are 5 layers, N plus P, N, P, N, 5 layers. This is one, N plus P, N, P, and N. 5 layers. It consists of 5 layers. T1 is the terminal from the N plus region, and T2 is the layer from the N region. Right. See, it conducts in both the directional. It's bidirectional device. So in one case it conducts in PN. So PN Pn layers will conduct during forward bias. When T1 is positive with respect to T2, then Pn is the conduction mode. It is in the forward bias. And in the second case, if you see here, Pn plus. In this, it conducts during the reverse bias mode. That means T2 is positive with respect to the T1. Now, the operation of the DIAC, you can see. It works on, it is a bidirectional device, that means it works on the alternating current. When the terminal 1 voltage is greater than the breakover voltage, then PN conducts in the forward bias. See here, I would like to say one point. SCR is DIAC is similar to the SCR except the gate terminal, and it conducts in both the directions. Right here, that means the characteristics are the forward characteristics of SCR is similar to the DIAC characteristics without gate terminal. That means whenever the voltage applied at the terminal, positive voltage applied at the terminal 1 exceeds the breakover voltage of the device, this middle layer junction breaks, and the current flows from T1 to T2. This is similar to the forward characteristics of the SCR. And if T2 is made positive with respect to the T1, if that terminal 2 voltage is greater than the forward breakover voltage 2, and the device conducts in reverse mode. From that means in this state the current flows from T2 to T1. The characteristics are in the third coordinate. Here also, see, you can see this. T2 voltage is greater than the breakover voltage 2. Then the device conducts. It is a bidirectional diode. The current flows from T1 to T2 or from T2 to T1, terminal 1 and terminal 2. See, you can see the characteristics of the DIAC. These are the characteristics: current versus voltage. Here also, see, this part is in the first coordinate. There is a forward bias, and here also reverse bias. It conducts in both the states. This is when T1 is made positive with respect to T2, right? In that case, this is M2 T1 blocking region. A small reverse leakage current flows until this applied voltage reaches this VB01. Whenever it exceeds this, the device conducts. It is in the conducting region. That means it is in the on state for the positive off cycle. See, positive off cycle means it can works on the alternating signal, and that is the reason. Suppose if the applied voltage is a positive voltage, until this voltage, this applied positive voltage is less than the VB0, there is a small amount of leakage current flows. Then the device is in the blocking region. It is in the off state. Whenever this positive peak voltage, positive signal voltage is greater than the VB01, all this middle junction also breaks. It allows the current from one terminal to the another terminal, and it is in the on state. That state we can say conduction region. And come to this in the third coordinate, right? Here up to this part also VB02 for the negative off cycle. Until it is less than the VB02, it is in the blocking region. A small reverse current flows. Whenever it reaches VB0 2, it comes into the conduction region and the device is in the on state for the negative off cycle. For positive off cycle, the device is in the first coordinate, the characteristics, and for the negative off cycle, and those are in the third coordinate. These characteristics are similar to SCR forward characteristics, but only the difference is it conducts in the two modes. See, in both the cases, the currents during blocking regions are very small and are called leakage currents, and both the directions are similar because doping level is same in all the layers. Generally, its breakover voltage lies between that VB01 and VB02 lies between the 30 to 50 volts in the DIAC, and the voltage drop across the device is 3 to 5 volts. The drop across the device when it is in the conducting mode, and in that case it is 3 to 5 volts. Means the resistance is very low when it is in conducting mode, and with that the drop is very less, it is less than 3 volts. When not conducting, if the device is in the off state, the device is not conducted, it acts like an open switch. See, a DIAC is also called a gateless triac. What is triac in detail we will discuss in the next session, next video. I will discuss it in the next session. Right, here DIAC is a two terminal device and triac is a three terminal device. Terminal 1, terminal 2, and it has one more additional terminal that is additional to the DIAC, that is called gate. That means if you observe this DIAC and triac, only the difference is for DIAC there is no gate terminal. That is the reason this DIAC is called gateless triac. And this DIAC is generally used for triggering of the triac. Whatever the device that is DIAC we discussed till now, generally it is used to trigger the triac. And it is a bidirectional device, so this DIAC can be switched from the off to on state for either polarity of the applied voltage. It can be operating on the on state with the either polarity of the applied voltages. Applications of the DIAC, where this DIAC can be used means, just now I said it is a triggering device for triac. Most of the cases it is used to trigger the triac. How it is we'll discuss in the next session. And light dimming circuits, heat controlling applications, universal motor speed control. To control the motor speed we can use this device. Okay, this is about the DIAC. Now let us I will give the brief summary of this session. See, in this session I discussed about the thyristor ratings. What is thyristor ratings means, for the proper operation of the thyristor the device, it should be operated within the limits, specified limits. These are called thyristor ratings. These limits are generally specified by the manufacturer. They will specify what is the maximum value, what is the minimum value. In the previous session also I explained what is latching current, what is holding current, this anode voltage and current ratings. These all are specified by the manufacturer. While operating this SCR, we need to manage the device within these limits. If these limits are exceeded, means the device automatically breaks. That is the reason we have to maintain these ratings properly. It should be less than this specified ratings. And one more thing, the turn on time of thyristor is the order of 2 to 10 microseconds. Turn on time. Now already we discussed what is turn on time. The time taken to come into the conducting mode, and that is it needs some time. The time is generally 2 to 10 microseconds. Waste very less time. And turn off time of the thyristor is between 50 to 200 microseconds. What is turn off time means? This turn off time is the time from the zero current to the device regains its conducting mode, blocking. That is called turn off time. It should be between the 50 to 200 microseconds. And the time taken to turn off the device, generally this the device turn off time should be always less than the circuit turn off time. That also we have to consider. If the suppose if the device turn off time is greater than the circuit turn off time, what will happen? Definitely it damages, right? It won't work properly. Now come to the DIAC. I explained about the construction of a DIAC. It has 5 layers. N plus region is on the near to the top of the first layer, and N is bottom of the that operating mode of the DIAC. It can operate in 2 modes. That means in both the directions, bidirectional. VI characteristics of the DIAC. VI characteristics, how it works, how it operates. Again, it has 2 states, conducting and blocking. In the blocking, also though the device is in the off state, a small amount of current flows. That current is called leakage current. We all know as that leakage current is due to the minority charge carriers. And this DIAC is also called a gateless triac. Applications of DIAC, where this DIAC can be used means mainly it is used for triggering of the device and a few another circuits, for the speed regulators, fan speed regulator, light dimmers, and the temperature controllers, like that. And there is one disadvantage of the DIAC: it is a low power device, right? If you observe, the breakover voltage of DIAC is of 30 to 50 volts. That means this device is coming into the conducting mode only within the range of 30 to 50 volts. If you recall the breakover voltage of the SCR, it is from 50 to 1200 volts. 1200 volts. So that can be operated used for high power and high powers to operate the high powers also. So the main drawback here, it is a low power device. It is a low power device. And one more thing, it has only 2 terminals, terminal 1 and terminal 2. There is no controlling terminal. It doesn't have any controlling terminal. These are the 2 drawbacks of the DIAC. Though it is operating bidirectionally, it can, but it is a low power device, and it conducts only there is no controlling element. Right, this is about the DIAC, and we will take a small case. Right, see, the first question is here: which one of the following is a triggering device? Which triggering device? We will see the options. A is the triac, DIAC, B is DIAC, GTO SCR, and all of the above. Triac, DIAC, GTO SCR, and all of the above. The answer is just now we discussed. The DIAC is used as a triggering device of triac, triggering for the triac. So triac. Now, which one of the following device is a gateless triac? Gateless triac. SCR, GTO SCR, DIAC, and none of the above. SCR has the gate terminal, and GTO SCR also has the gate terminal, Fourth option is none of the above. Only the DIAC is a two-terminal device. There is no gate. So the answer is DIAC. Turn off time of an SCR is measured from the instant anode current becomes 0. How when the turn off time will be measured means when the anode current becomes 0, or B is anode voltage becomes 0. Anode voltage and anode current becomes 0 the same time, and the fourth option is gate current becomes 0. What is the question? Turn off time of an SCR is measured from the instant anode current becomes 0. From the instant whenever the anode current becomes 0, the turn off time starts. With considering again two times the reverse recovery time and the recombination time. And the next question, for safe turn off of SCR, the circuit turn off time, and the option is A, must be greater than device turn off time. For safe turn off time of SCR, the circuit turn off time must be greater than device turn off time. B is must be less than device turn off time. Either A or B, or it may be either anyone or none. And the answer here is must be greater than device turn off time. And from these topics, what are the questions we can expect means, from the ratings of the SCR, what are the different ratings of the thyristor? What are the voltage, anode voltage rating, current rating? Those we can expect either for short answers or for long answers. For with define means we can expect in the long answers. List means we can expect in the short answers. And next question, define the turn on and turn off time of the SCR with characteristics or without characteristics. That is a different case. Draw the turn on and turn off characteristics of a thyristor. This is another question. Draw and explain the cross-sectional view of the DIAC construction. Cross-sectional view of the DIAC, and write any 4 applications. What are the applications of the DIAC, where the DIAC can be used, or and we can expect the question. Draw and explain the VI characteristics of the DIAC. If it is for short answer, only simply draw the VI characteristics. If the question is in the long, and that means we need to explain VI characteristics. That means the how it is, where it will be, when it is in the blocking mode, when it is in the conducting mode, and what are the conditions it is in the on state and it is in the off state. All can need to explain in the VI characteristics of the diode. So we can expect anything from today's topic, either from either into the long answers or short questions. Okay. See, in today's session, I explained about the thyristor ratings and the constructional, what is a DIAC, how it is constructed, and how it is operating, and this all we explained. In the next session, I am going to explain about the triac, and also about the SCR triggering by UJT. SCR triggering by the UJT and the triac characteristics, as well as applications and advantages of the triac. See, triac is also a type of operating device, power device. This is also a power device, right? Okay. With this, I am going to end my session. Okay, thank you for listening this session, and read it carefully.